Geometry Common Core, Regents Review, Video 7. In the diagram below of triangle HAR and triangle NTY, angles H and N are right angles. We see that with these little boxes marked. Let me zoom in, make this picture a little bit bigger for us. And they are similar. So the fact that these triangles are similar means we know a few things. We know corresponding sides are proportionate. Corresponding sides, let me write this a little bit neater. Corresponding sides, maybe I could use that dot for the I. Corresponding sides are proportionate and corresponding angles are congruent. Just like angle H and angle N, we know they're both 90 degrees. So if they say that AR equals 13, so where's AR? Here's AR, the hypotenuse, and HR equals 12, what is the measure of angle Y? All right, so this is the angle. I'm going to put a little theta symbol in there. We'll try to put a little theta symbol in there. So what we know about similar triangles is corresponding sides are proportionate, corresponding angles congruent. So angle Y, whatever the measure of angle Y is, it's the measure of which angle over here. Well, it's very helpful that they always list them in corresponding order. That we see that since Y is the last in that triangle, that means R is the last in this triangle. So that means we're really finding this angle as well. And so you don't have to worry about not having the sides of this triangle, because I could use the sides in this triangle, because finding this angle is the same thing as finding that angle, because corresponding angles are congruent. And the way we find angles such as this would be an inverse trig question. And so what do we have? From angle theta's perspective, this is adjacent and this is hypotenuse. And as we've learned from previous videos, and we know that sine involves opposite and hypotenuse, that's not it. Cosine involves adjacent and hypotenuse, and that is it. Tangent, which again not using right now, but that would be if the hypotenuse was not involved and it was just the opposite and adjacent. So this is a cosine question. Now when you're doing trig to find angles, instead of doing regular trig, you have to do inverse trig. And so this would not just be regular cosine, it would be inverse cosine. We get that little -1 symbol, which stands for inverse. And then instead of having the angle equal to the ratio, we put the ratio on the same side with the inverse cosine, adjacent over hypotenuse, and this is going to equal the angle theta. And really from here it's just a calculator topic, and we just got to type in the right buttons. So let me pull up my calculator. Now you should make sure your calculator is on and that the mode is in degree. So I need to go and put my calculator on degree mode. Yours is most likely on degree mode, but you should check it. Now the way we get inverse cosine is with the second key in our calculator. So second cosine, 12 divided by 13, and we see that this angle is about 22.6, so about 23 degrees. And so that's where we are going to get our answer. So remember that trigonometry comes from similarity, because similar triangles have corresponding angles and proportionate sides. So if they tell you triangles are similar and want one angle, well, you can really find the angle or the corresponding angle in the other triangle. All right, let's move down to number 2. Number 2, given right triangles ABC with right angle at C, measure angle B is 61, and giving right triangle RST with right angle at T and angle R is 29. Which proportion in relation to triangle ABC and triangle RST is not correct? So again, when they talk about proportions in multiple triangles, are these triangles similar? Well, what do we know? This angle is 61, this angle is 90. How do I find that third angle? Well, we would just take 180 and minus the 61 and minus the 90. And what does that leave us with? That would leave us with 29. So this angle is 29. And this triangle has 90, 29. So this has to be 61. So are the triangles similar? Yes, because, oh, that's a little too zoomed in. The triangles are similar because of the angle-angle theorem. If corresponding angles are congruent, then the triangles are similar. So that means, yes, they are proportionate. And again, now that we know they're similar, I think you really want to just focus on the order of the letters. So let's see, AB over RS. AB is first, second, RS is first, second. And then RT and AC. Now it's right corresponding, but notice that triangle AB is on top, but then for the second fraction or second ratio here, AC is on the bottom. That is not correct. And we're looking for not correct. So that's probably our answer, but I'm going to put a little F there for false. Let me check the other ones. So I'll erase this so I can mark it up each time. BC over ST, they correspond, and AB over RS. And again, triangle ABC is on top, triangle ABC is on top. So this is true. BC over ST, which is again that same pair. AC over RT, AB on top, ABC on top. Another true. AB over AC. So this, instead of like one from each, this is, you know, two from one. AB is from this triangle and AC is from this triangle. RS, RT. Again, so you could do a two from one proportion or like a, you know, large over small proportion, but it corresponds. It's in the right order. It is true. All right, let's move over to number 3. Kelly is completing a proof based on the figure below. She was given that angle A, let me get a better arc there. Angle A is congruent to angle EDF, that angle there. And has already proven AB is congruent to DE. So she's got the S and the A. Well, that means we could potentially be getting side angle side, or maybe angle side angle. You know, so there's a couple options that might work here if we're trying to prove these triangles congruent. Which pair of corresponding parts and triangle congruency method would not prove them congruent? Okay, we could also be getting angle angle side here. I'm willing to bet one of these cases, and they even tell you the methods here. You know, right away, the fact that I see two side angle sides, I'm guessing one of them is true, one of them is false. But let's check all of our options here and see what happens. So if we were to add AC congruent to DF, is that side angle side? Side angle side. Side angle side, remember that's two sides and the angle between. Two sides, angle between. So yeah, that's true. What if we were to add, now the fact that that's true means this one's probably not. What if we were to add BC and EF? Would that be side angle side? It's two sides, the angle's not between them. Like if you just focus in on this triangle for a second. We got this side and this side marked up, and this angle. That's not the angle between them. The angle between them is where the sides meet. These two sides meet here, so it has to be this angle to be side angle side. Let me get rid of all that ugly thick markings there. So that's why that's false, and that's going to be our answer, but I'll check the other choices because you always want to check all four, because if I get something else that's false, I'll catch a mistake. If we add angle C and angle F, we already have this side too, is that angle angle side. Yeah, so the difference between side angle side and angle angle side, you know, here you got two angles, the side not between them. If it was angle side angle, it'd be two angles and the side between them. So the order really matters, but it is true. And how about if we were to, instead of adding that, add angle CBA, this angle, that's angle side angle. So again, you see similar, you know, two angles and a side like this, but the sides between them, the sides not between it, but it's true. So we were right with our initial assessment there that choice B is false. And the fact that you have two side angle sides, I think, kind of makes that obvious that one of them is going to not be true. All right, finally in number 4, in the diagram below, triangle ABC with sides 13, 15, and 16 is mapped onto DEF after a clockwise rotation of 90 degrees about point P. So we rotated this way and it fell on top. The fact that it falls on top means these triangles are congruent because a rigid motion maps it onto it. If DE is 2x plus 1, what's the value of x? Okay, and these triangles are congruent, but what is DE matched to? Is DE 15? Is it 13? Is it 16? I mean, you can kind of just picture the rotation happening, but again, don't forget that they give it to you in corresponding order. So DE is the first two letters here, so that means it matches with AB. AB is 16, so that means that this equals 16. So 2x minus 1 equals 16. A little bit of basic algebra. Add 1 to 17, divide 2. Now 17 is not an even number, so you're going to get a decimal, 0.5. It's going to work out to be 8.5. All right, so that's it for Regents Review video 5. Or what are we up to? This is 7. Sorry, Regents Review video 7. And I think they're going to have 10 videos total in the series. maybe 12. We'll see. But good luck on your regions. Keep watching. Bye.